We're asked to determine whether this function is 1 to 1 and then write an equation and then graph both f and the inverse, obviously if it exists, and give the domain and range of both. This is a great place to use your graphing calculator. Now obviously it's important that you can graph things by hand, but when you're trying to quickly determine whether things are 1 to 1, the graph is the best way to figure that out, just like it's the best way to figure out if something is a function. And your graphing calculator will allow you to quickly do that. So I'm going to pull up my graphing calculator. And I need to put this in. Remember, f of x is just y, so I'm going to go here to y, and I'm going to put in x to the third minus 7. Make sure that you get out of the exponent. It'll a lot of times keep you up there. And then I'm going to go to the graph. And this is quickly going to give me my graph. I can run the horizontal line test. This is 1 to 1. I can then find the equation of the line. So to find the equation of the 1 to 1 function, I switch the places of x and y, and I solve for y. So then I get the inverse is the third root of x minus 7. So I switch the spots, and I'm trying to solve for this y, so I have to add up plus 7. It's a good thing I started talking while I did this. Plus 7, because I had to move it to the other side, and then I took the third root of each. So, how are we doing so far, now that I checked my things? Now, I want to find both. So, I've already got one of these graphed. I need to now go graph the other one. So, I'm going to add this, and I want now the third root. Remember, the third root is just, you can rewrite as a fractional exponent. So, I'm going to do x minus 7. Now, I really want to make that minus, don't I? X plus 7 to the, and I'm going to do 1/3 power. This is the same as the third root, okay? So I have given the third root, but I'm using it as an exponent to make it easier to put in my calculator. And then I'm going to go to graph. And right here, it gives me my graph. And you'll notice something about these. Where are these symmetric about? They're symmetric about the line y equals x right here. If I put this down here, straight down, and I flipped them over, they're going to be symmetric about this line, the line y equals x is diagonal. We're used to things being symmetric on the x or y. Inverses are symmetric right here across the line y equals x. So now I can come here. Now, of course, if I wanted to look at this and kind of know, I'm not sure about the points, I want some actual points, second table here. And this is going to give me a list of the points of this. And I can, of course, change this to whatever I want. If I go here to table setup, I can decide that I want this. I want to start at, -5, and I want to count by 1/2. And it'll go and change it. I go back to the table, and it's done that. Obviously, the ones are usually nice, but you can do however you want. So I come here, I'm going to go back to my graph here so I can see it. And let's see here, that one and this one, because there's that one, so it's C. And then give the domain and range. Again, this is where the graph very useful. So F, what's the domain? That's the x's. Well, this is all x's, right? So -infinity to +infinity. And the range, same thing. It can be any of these, -infinity to +infinity. Okay. Now, domain and range of f prime. Same thing here. I can be any x, I can be any y. But I find domain and range, the best way to find them is with a graph. I want to see, come on, negative. For some reason the keyboard isn't wanting to type for me. Oh, I don't want -infinity to -infinity. That looks pretty crazy. Okay. -infinity to +infinity. And there we go. So you can see that with these problems, the inverses, this is a really quick and easy way. Using your graphic calculator can really help you get these graphs up. Now you should know how to do them by hand, but as you're starting to do other stuff, let the graphing calculator do some of the mundane lifting for you so you can concentrate on learning how to work the inverse itself.